I got sent a note here, the forged yoke handle design. I don't know which one of you want to touch on that a little bit, but I think it's worth noting. So that's kind of specific, not specific to the Canadian market, but
Yeah,
It
a
was
value.
designed here. Yeah.
Yeah.
yeah, no, definitely. I mean, I can speak to that. Like, it essentially came out of the Canadian market, kind of as a request from customers, basically being like, "Hey, we have this OEM design that was fine but not great. They had some issues with it.
Yeah.
Weren't getting the life basically because of challenges." But yeah, basically, I think the story was we were actually approached by a mine originally, and kind of as like, "This is the problem. Can you guys help us?"
And what was the problem?
It was basically essentially it was cracking that would take the handle out of service. Cracking obviously for a variety of reasons, material design and how it was actually designed. Really probably a little bit undersized for the machine it was actually operating on. And then we were basically able to take it and kind of upgrade it and change out a few, forging or put forgings in where there's castings and so forth.
So why was it like the density of like why did it come undersized from the OEM? Because like was it the density of the material, or what was sort of causing that initially?
I think, correct me if I'm wrong on this one, but I think it was that some of these machines are legacy machines of multiple years.
Yeah.
So like, a rope shovel has been built 100 years ago when it started, and over the years they've added, made bigger. So obviously they don't redesign a machine, every generation. They redesign components of it and make it a bit bigger, put a bigger dipper on it and so forth.
Right, but every component does get swapped out just because you made
Yeah, so it was probably essentially the one component that was now too small for the machine or under-designed for the size that it was operating in.
Is that fairly common to see that kind of thing happening?
I'd say I don't. Yeah, I mean, there's always.
I'm not trying to pick on any of the
something.
OEM.
Yeah,
It's just
there's always something there. And then the other thing is that it was like that particular product was a casting, and when you have a casted product, it is very hard. When you get that cracking, it's hard to fix it out there in the field. So you almost have to have it because you got pre and post heats on the welding.
Yeah.
And once the OEM's handle started to crack, I mean, it was just perpetual, and you couldn't get ahead of it. And that's why we changed to the yoke. The forged, fabricated yoke is just for the being able to fix it in the field.
Yeah, and then what happens? So again, just on that business development side, so what happens? You change one, and then now people start to know that that's happening, right? So then, because even a capacity issue, you think even if it's maybe another operator is not cracking as fast, I'm imagining you're increasing capacity, right?
Yeah.
Mm-hmm.
Yeah.
And a lot of that stuff comes back to we have to do, you have to go out there and look at that market and say, is it customer specific that's having this issue, or is this an issue throughout the industry?
Yeah, and this was
one
industry.
was throughout. Yeah, it was an industry issue.
And so before that, client was just everybody out there struggling with it then, and then
yeah, I mean you've got a parameter that they hand you, like this. If it's cracked, here's how you fix it. So everybody was out there doing it, but you're talking about line of fire. You got guys out there working in the field. You got safety hazards, so on and so forth. So if you can fix some of those issues. Yeah.
Yeah. The one thing I'll make a note on that too, that I thought was kind of cool with it is the handle is basically, it's a big tube with kind of a fork on the end. And typically if it breaks, you can, like Dustin said, you repair it, but it's a casting, it's hard to repair. But with our design and what we're able to actually do is we were able to reuse the tube. So if you have a customer that has a handle in the tube and it's broken or it's, reached its service life, it's often just the fork end, the yoke end, that's basically houred out.
Yeah.
So we can actually cut the tube off of it and then put the tube onto a new end. And then that saves a huge cost because you're not buying a new tube every time.
Are you doing a lot of stuff like that as well? Taking an OEM's design and going, okay, well, this is the wear. Do you ever turn a part that typically wasn't a wear part? It almost sounds like that's what you're doing. You're kind of breaking up the piece, basically.
Yeah.
Right.
Eventually, yeah.
Yeah. What about on the undercarriage? I wanted to bring that up too, because that you're very strong in that space, right?
Yeah.
The undercarriage design.
Yeah.
Mm-hmm.
Yeah.
Yeah, I was gonna say it was probably very similar. Again, Dustin can speak on the long-term history of it, but same thing. Like, we had customers that weren't seeing the life that they wanted, or they're having failures, like say they're breaking track pads, or they're having premature failures on idler wheels and so forth. And obviously, every time you have a failure, you got to take the machine out of service. It often interrupts your maintenance schedule, right? So you're trying to base everything around a set timeline where you're taking machines down. So it was costing more money all around, both parts and intervals. So yeah, we kind of worked through some of the challenges that they were seeing with that. to basically maximize, say, shoe life or increase idler hour life through a bunch of obviously design tweaks and whatnot. And yeah, I know it's been really successful.